Get ready for an exciting adventure into the life and genius of one of the greatest minds in history, Sir Isaac Newton. Ever wondered how a falling apple led to groundbreaking scientific laws? Stay tuned as we uncover Newton's genius, his famous 3 laws of motion, mysterious facts, and a secret that will shock you. But before we begin, don't forget to like, share, and subscribe to our channel for more amazing content. Born on January 4th, 1643 in England, Isaac Newton's early life was full of struggles. He was a curious child, fascinated by nature and mechanics. From making his own sundial to experimenting with windmills, young Newton was always questioning the world around him. But little did he know, he would one day change science forever. As Newton grew older, his curiosity led him to a moment that would change science forever. But what made Newton a legendary scientist? Well, it all started with a simple apple. Have you heard about the most famous Newton story? The apple falling from a tree. But did an apple really fall on his head? Well, not exactly. One day, while sitting under a tree, Newton observed an apple falling straight to the ground. This made him wonder, why do objects always fall downward and not sideways or upward? This simple observation led him to discover the force of gravity, a force that holds everything together from us on Earth to the planets in space. But wait, if gravity pulls everything down, why don't the moon and planets fall straight into the sun? Think about it and comment your answer below. To understand this, let's explore Newton's 3 laws of motion. The small observation about gravity led Newton to something bigger, his famous 3 laws of motion. Now let's break down Newton's 3 laws of motion in a simple way. Law 1. The law of inertia. Before moving forwards, let's understand simple terms force. Force is simply a push or a pull. Imagine you are kicking a ball. Your foot pushes the ball, making it move. If you pull a toy car with a string, that's also a force. Now move to law of inertia. An object at rest stays at rest. And an object in motion stays in motion unless acted upon by an external force. Imagine a ball on the ground. It won't move unless you kick it. But once it's rolling, it won't stop until friction or another force slows it down. That's inertia. Have you ever thought, if Earth moves so fast, why don't we feel it or fly off? Because everything, including us, is moving at the same speed. Newton's first law says we stay in motion unless something stops us, and gravity keeps us on the ground. And here is the answer of our question as well. For the same reason, planets and the moon don't crash into the sun. But wait, there's more. The second law reveals something even more fascinating. Let's understand mass and acceleration before understanding second law. Mass is the amount of matter in an object. It tells us how heavy or light something is. Example, a big rock has more mass than a small toy car. Acceleration is how fast something speeds up or slows down. Example, when you ride a bicycle and start pedaling faster, you are accelerating. Now, let's get hold of Newton's second law. Force equals mass times acceleration, or F equals m multiplied by a. The heavier an object, the more force needed to move it. Try pushing a bicycle or then a car. Which one is harder? That's Newton's second law in action. Now let's test your thinking. If you drop a rock and a feather, which will move? Faster? Put your answer in chat box. Any guess? Here is the answer. In a vacuum, both fall at the same speed. Because Newton's second law shows gravity affects all objects equally, but air slows the feather down on Earth. Next, we'll have third law of motion, action and reaction. For every action, there is an equal and opposite reaction. When you jump, you push ground down, and in return, ground pushes you up. Have you ever wondered? Birds and rockets? Use the same principle. Birds push the air backward with their wings, action, and the air pushes them forward, reaction, just like how rockets push gases downward to move up. Yes, that's how rockets move in space. Speaking of Newton's genius, did you know he wasn't just a scientist? Here's a fun fact. Newton was also a mathematician, an astronomer, and even a philosopher. He invented calculus, a math tool that scientists still use today. Now let's put your imagination to the test. Here's a fun question for you. Why does a heavy truck take longer to stop than a small car? Put your answer in chat box. Any guess? Here is the answer. Since the truck has more mass, it needs more force to slow down. That's why big vehicles have powerful brakes. Newton's other inventions. Newton didn't stop at gravity and motion. He made even more discoveries that changed science forever. He built the first practical reflecting telescope, studied light and colors, and even worked on alchemy. His work changed the way we see the universe. But what if I told you Newton was searching for something even more mysterious? Newton was not just a scientist, he was also obsessed with alchemy, an ancient practice of turning metals into gold. He spent years trying to create the philosopher's stone, a mythical substance believed to grant eternal life. But did he succeed? Let's check this out in a while. Newton's discoveries shaped modern science. He became the president of the Royal Society, was knighted by Queen Anne in 1705, and left behind a legacy that still inspires scientists today. But about that secret, before we end, let's reveal the truth behind our secret. Despite his obsession, Newton never found the philosopher's stone. However, his work on chemistry laid the foundation for modern scientific discoveries. Even though he didn't create gold, his knowledge was more valuable than any treasure. Newton's genius changed our understanding of the world. From gravity to motion, his laws shape everything around us. If you enjoyed this video, make sure to hit the like button, subscribe, and turn on notifications for more exciting content. See you next time.